Okay, now we move to a new chapter, new lesson, one sample test of hypothesis. Okay, of course, in the previous chapter, of course, estimation and confidence interval. The previous chapter is about estimation and confidence interval. Of course, we were concerned about developing a confidence interval, of course, which is basically a range of values, okay, constructed from a sample that, we expect the population parameters such as the mean to, to occur within that range. Now, today, of course, in this chapter, of course, rather than we develop a range of values within which we expect the population parameters, such as the mean, to take place, what we will do, we will develop a procedure to test the validity or the reasonableness of a statement about a population parameter. So we have a statement, okay, or a hypothesis, and we're going to test the validity or the reasonableness of that statement or that hypothesis, okay? So an example of a statement that we might be concerned to test. It's like this: the mean time an expatriate worker lives in any Arab Gulf state is 10 years. This is a statement, it's a hypothesis, okay? So we need to test, after we collect a sample data, to test the validity or reasonableness, the reasonableness of this statement. So in this chapter, of course, we're going to focus on statistical hypothesis testing. What is a hypothesis? A hypothesis is a statement about a population parameter. Population parameter, like the mean or the standard deviation. Okay? The mean of the population, subject to verification. As you know, in most cases, the population is so large that it is not feasible to study all the objects, or persons in the population. Therefore, a sample, the alternative to interviewing the entire population, because the population is so large, to interview every subject, every object, every person in that population. What is the alternative? The alternative is to take a sample from that population. Okay? And we use that sample to test the validity of the statement or hypothesis about the population parameter. What is hypothesis testing? Of course, notice that hypothesis testing and testing a hypothesis are used interchangeably. Either we use this or that. They mean the same thing. If you say hypothesis testing or testing a hypothesis, mean the same thing. So they can be used interchangeably. Hypothesis testing starts with a statement or assumption about a population parameter, such as the mean, such as the population mean. Like this statement over here. This statement about the population mean. The mean time an expatriate worker lives in any Arab Gulf state is 10 years. Of course, there are thousands upon thousands of expatriate workers who work and live in any Arab Gulf states. So it's not feasible to interview all those expatriates. So we just take a sample of those expatriates, okay, in order to test the validity of the population parameter. Okay, this statement is called a hypothesis. So the statement like this one here, the mean time an expatriate worker lives in any Arab country, in any Arab Gulf states, is 10 years. This is a hypothesis. This is a statement. Of course, it's a claim that we need to test that claim or this hypothesis. So, a hypothesis testing, okay, or as we said here, testing a hypothesis is a procedure based on a sample evidence. So we need a sample because it's not feasible to interview all objects or subjects or persons in the population. So the hypothesis testing is going to be based upon a sample taken from that population. For the sample evidence and probability theory. So we need to mix probability theory, as we can see later, shortly, in the 5-step procedure to test the validity of a statement. So we say it's a procedure based on a sample evidence and probability theory to determine whether the hypothesis or that claim or statement is a reasonable statement. Okay, now we move to talk about 5-step procedure for testing a hypothesis. We said before, a hypothesis is a statement about the population. So, as used by statisticians or researchers, hypothesis testing, which is a decision-making process for evaluating a claim about the population, okay, it does not provide proof that something is true. All we have to do is that the researcher in decision-making process, of course, usually define a population, of course, set up the hypothesis that he is going to investigate, of course, set up or define or give the level of significance, and then select a sample data from the population in order to do what? In order to test the reasonableness of the hypothesis. Okay? So, as said, the hypothesis testing does not provide a kind of proof. It does not provide that something is true. However, as I said, it only tries to test the reasonableness of the statement. It doesn't provide a kind of proof beyond a reasonable doubt. Okay? Of course, there are certain steps. Here, we're going to have 5 steps, of course, that are used by the statisticians or the researcher in order to test the reasonableness of the statement or the hypothesis. Of course, we start with first step, which is first the researcher must state the null hypothesis, okay, H sub 0. It's read as H sub 0, and the alternate hypothesis, which is read H sub 1. H stands for hypothesis. H sub 0, okay? Null hypothesis, H sub 0, read H sub 0. Okay? And H stands for hypothesis. Now, what is the null hypothesis? Of course, is a statistical hypothesis that states that there is no difference between a parameter and a specific value, or states that there is no difference between 2 parameters. Of course, in the null hypothesis, of course, as we see over here, we always, the equal sign is always a part of H sub 0. There's no difference. So, as I said over here, for instance, H sub 0 mu the mean is equal alpha, or h sub 0 mu less than or equal alpha, or h sub 0 mu greater than or equal to 0. So as you can see here, that the equal sign is always part of the h0, of the h sub 0. The equal sign is equal part of the h sub 0, okay? So here we're talking about the null hypothesis. Of course, the alternate hypothesis, which is symbolized by h sub 1, okay, is a statistical hypothesis that states the existence of a difference between a parameter and a specific value, okay? So if the h sub 0 states equality, then of course the h sub 1 states that there is a difference that is, not equal, okay? Or states that there is a difference between two parameters. Look over here how we, illustrate the h sub 1, okay? Of course, we always have a not equal, less than, or greater than for the h sub 1. So h sub 1 here, for instance, mu, if we're talking about the mean of the population, then h sub 1 is going to be mu is not equal to alpha, or mu less than alpha, or h sub 1, which is the alternate hypothesis, mu less than alpha, or we can have a different version or a different, alternate hypothesis, which is h sub 1 mu greater than alpha. So this is actually how we designate, the null hypothesis and the alternate hypothesis. Remember that in the null hypothesis, equality is always present, okay? Equal sign or not equal, less than or equal, or greater than or equal. However, in the alternate hypothesis, we're going to have not equal sign, or less than, or greater than. Now, let's look at hypothesis testing common phrases. Of course, in solving problems about hypothesis testing, you're going to encounter certain phrases. We need to basically understand the meaning of them and how to use, the relation greater than or less than, or greater than or equal, or less than or equal or not equal, based upon the concept, or the phrase that is presented. For instance, is greater than, or if you see the phrase is greater than, or is bigger than, or is increased, or is above, or is higher, we use a greater than like this. Okay? The inequality is greater than. Okay? However, if you see in an example or in a question or a problem, phrases like is less than, or is decreased, or is above, is lower, or is below, or is smaller, then it means we have to use less than in the, of course, alternate hypothesis, or even in the null hypothesis when it is less than or equal. So usually less than or greater than are used with the alternate hypothesis. Okay? Now, however, if you see phrases in any statements or any problem, such as is greater than or equal, we use a greater than or equal sign, like this. Is at least, we use a greater than or equal. Is not less than, we use a greater than or equal. Here, if you encounter phrases like is less than or equal, then we use less than or equal sign. If you encounter a phrase like is at most, then we use less than or equal, this sign over here. if you encounter a phrase is not more than, we use this, inequality, this equal inequality, less than or equal. Now, we move to the equal side. If you encounter a phrase is equal to, or has not changed from, is the same as, or is exactly the same, then we use the equality sign. Whenever you encounter these phrases, you use the equality sign. On the other hand, if you encounter these phrases is not equal, or is different from, or has changed from, or is not the same as, we use, the not equal sign. Usually the not equal sign is used in the alternate hypothesis. So actually, we should understand these phrases so that when we state the null hypothesis and the alternate hypothesis, we state them right. Let's give an example of the first step of this 5-step procedure for testing a hypothesis. An example of how hypothesis is stated. Let's say the first example, an engineer hypothesizes that the mean number of defects can be decreased in the manufacturing process of inverters by using robots instead of humans for certain tasks. The mean number of times is 20. Now, in this question, we need to state the null hypothesis as well as the alternate hypothesis. As you can see here, the engineer hypothesizes that the mean number of defects can be decreased. So the alternate hypothesis is that the mean is less than 20, because the mean number of defects is 20, and he is hypothesizing that it can be decreased. That means it's less than. Okay, so the null hypothesis is going to be the mean, or the mu, is greater than or equal to 20. Remember that the equality sign is always written in the null hypothesis. Always in the null hypothesis we have the equality sign. Okay. Now here we have the equality greater than or equal 20, and the alternate hypothesis is that the mu is less than 20. Okay, this is how the engineer is hypothesizing about the mean number of defects. So he said it can be decreased, therefore the alternate is that mu less than 20. Now let's look at the second question. The second question says, a psychologist feels that reading the Surat al-Falaq during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean of the scores was 70. So here, psychologists feel that reading the Surah Al-Falaq during a test will change the results of the test. Okay? So now here we have, of course, a two-tailed test. Of course, here we know that the null hypothesis is that mu is not equal 70, and the null hypothesis is that mu equals 70. Okay, will change. Okay, change, of course, is different. Okay, that means we're going to use the equality sign. Now look at the third question. a physics invents an additive to increase the life of an automobile battery. Okay, this is the hypothesis. This is the statement. Okay, to increase the life of an automobile battery. If the mean lifetime of the automobile battery is 48 months. So now how we going to state the null as well as the alternate hypothesis? Of course, his claim is the additive that he invented will increase the life of an automobile. Increase, it means greater than. So we said mu greater than 48, that's the alternate, and then the null hypothesis is going to be the mu less than or equal 48, months. Okay? Now, step 2, okay, select a level of significance. Then step 2 from the 5-step procedure for testing a hypothesis is that select a level of significance. Select a level of significance. The level of significance is the probability of rejecting the null hypothesis when it is true. Okay? It's sometimes called the level of risk. It is assigned the Greek letter alpha. So alpha is the probability of rejecting the null hypothesis when it is true. The common levels of significance that are used in tests, either 1% or 5% or 10%. Now, type 1 error, which is rejecting the null hypothesis at sub-zero when it is true. Remember, it happens when you get a false positive result. Okay, suppose your results, of course, you conclude that a certain drug intervention improved the symptoms of the disease when it actually did not. When it actually, the null hypothesis, it did not. Therefore, here we're saying, rejecting the null hypothesis, okay, when it is true. So, type 1 error, type 1 error is actually happens when you get false positive results. Now, of course, the probability of committing a type 1 error is alpha, the Greek letter alpha. And the probability of committing a type 2 error is beta. What is type 2 error? Is accepting the null hypothesis when it is false. The same thing, it happens when you get false negative results. Suppose you conclude that the drug intervention did not improve the symptoms of the disease when it actually did. This is type 2 error. We're going to refer to type 2 error by the letter beta. Okay, now still we are going over the steps in the 5-step procedures for testing hypothesis. Step 3, select a test statistic. So we have 5 steps that we have to go through in order to test any statement about the population, any hypothesis testing. Step 3, of course, select the test statistics. Of course, in this chapter, the Z and T tests are used. So here we're going to be, using either the Z test or T test. Of course, that depends, whether the standard deviation of the population is known or unknown, as we will see shortly. A test statistic is a value determined from a sample of data selected from the population, which is used to determine whether to reject the null hypothesis or not to reject the null hypothesis. Okay? This is a test statistic. As I said, the test statistics is calculated based upon whether the population standard deviation is known or not. If it is known, we will use these statistics, as you will see on the board. And if it is not known, then you will use the t statistic. Okay. Here, we're going to be focusing upon hypothesis testing for the mean of the population. We use the z statistics if the standard deviation of the population is known. So in the question, of course, you will see that shortly when we begin applying these important, concepts in this chapter. We're going to apply them with problem solving, of course. We will see basically, how, z is calculated and when it is calculated and how t is calculated and when it is calculated. So here we will use the z statistic if the standard deviation of the population is known. So in the problem, if it is mentioned that the standard deviation of the population is known, then to calculate the test statistic, we use the z. Okay, we calculate the z statistic. So the z statistic, as you see here, is equal. The formula for the z statistics or the test statistic is x bar minus mu over sigma over radical m, where x bar is the sample mean, which is equal, the summation of all values in the sample over the number of the values. Mu is the mean of the population. Sigma is the standard deviation of the population. Okay? And n is the sample size. We use the t statistic if the standard deviation of the population, sigma, is unknown. So in the problem that we are solving, if the standard deviation is not mentioned, that is, it is unknown, then we will use, instead of z, we will use the t statistic. So t statistics, the formula of t statistics is t equal x bar minus mu over s over radical n, where, of course, s is the sample standard deviation, which is used to estimate the population standard deviation that is unknown. Okay, S is sample standard deviation. Okay. It is used to estimate the sigma, which is the population standard deviation. Step 4, formulate a decision rule. We have to formulate a decision rule. The decision rule is formulated by finding the critical values of z if sigma is known by using table B1 in the appendix. If sigma is unknown, then we find the critical values of t from table B2, B.2 in the appendix. Of course, these will be, verified and seen shortly when we write the questions and solve the problems. We will show you how we calculate the critical values for z and for t. Okay? The critical value is basically the critical value is the dividing point between the region where the null hypothesis is rejected and the region where it is not rejected. We will see that shortly, of course, when I graph, when we talk about one-tail test or two-tail test. We're going to graph the normal curve and show you, whether we have one tail right test or one tail left test, or we have two tail tests. We'll show that, later. Of course, step 5, the last step, is make a decision and interpret the result. So the last step in this 5-step procedure is to make a decision and interpret the result. Of course, to do that, you should take a sample from the population, compute the statistic, the test statistic, whether it is Z or T, depending on whether the standard deviation is known or unknown. Compare it to the critical value, whether it is bigger than the critical value or smaller than the critical value. If it is bigger than the critical value, then it is in the critical region, in the rejection region. And if it is not, if it's smaller than the critical value, as we will see later, then it is in the acceptance region. And take a decision to reject or not to reject the null hypothesis. Remember, in hypothesis testing, we have a decision, we have one decision is possible, either to reject or to accept.